Hi everyone. Here question is conversion of NFA to DFA using subset method. What is subset method? That I will explain parallelly. What are the steps involved here? First step, NFA state transition table is given. In other question you may have given NFA state transition diagram. So first you need to convert that NFA state transition diagram to NFA state transition table that already we have given in this question. So in the first step what we will do, we will first derive NFA state transition table to DFA state transition table. Post that we will draw DFA state transition diagram, or I can only say DFA. So let's start. How we can convert NFA state transition to DFA state transition table. Here column headers will be as it is. For example, here 0 and 1 will be as it is. The first row Q0 I will be taking as it is, that is the starting as well as final state. Subset construction method notation is optionally we can give this square bracket here. This is the optional one, you can ignore also. What is exactly we are doing? Let me explain. NFA property says that, for example, here Q1 is a state on reading 1 going to Q0 comma Q1. These are the two states. That's what non-deterministic property. I have explained this with examples what is deterministic and what is non-deterministic in one of the basic video. You can watch it again by using the above link. So Q1 on reading 1 going to two states actually here, Q0 comma Q1. That is ignored in the NFA. You can use this notation or it can be ignored. But here are the two states Q0 comma Q1. But this is not allowed in the DFA. Deterministic says that on reading one symbol, a state can go to only one state. And we have to remove this property then. In DFA, by reading one symbol, one state will go to only one state. This Q0 comma Q1 is not allowed. So we need to remove this. So that's what our process. So first row Q0 on reading 0 on reading 1 going to Q0 Q1. Well, conversion you can copy the first row as it is. No need to worry about the first row. So I am copying it as it is Q0 and Q1. As a subset notation method I can give the here square brackets. Now here Q0 on 0 going to Q0, Q0 on 1 going to Q1. So here whatever the states are created, those states are called as a subsets. So new subset is created Q0, but it's already taken by us. Q0 row is taken care. Then new subset Q1, Q1 row is 8 to derive transition for this Q1. So whatever is new, Q0 is done, Q1 is done, no. So take Q1. So write down this Q1 as it is. Here we will be filling this DFA state transition table using NFA table, using this table. How? Suppose here first row we copied as it is. Now second is Q1. For Q1 we need to derive for transition for 0 and 1. For example, Q1 on reading 0. So here is a Q1 on reading 0. Where it's going? It's going to Q1. So I'm writing here Q1. This is a notation. Q1 on reading 1. It's going to two states, Q0 and Q1. But subset method says that we will be combining these two states now. In the NFA table it's a Q0 comma Q1. But in the DFA table it will be combined. How? I'll be writing this like this, Q0, Q1. It looks similar, but here Q0 comma Q1, it may be or it may not be given, but these are the two states. But in our subset, once we give this bracket, this is considered as only one state. For example, let me write this in terms of diagram notation. See, this Q0, Q1 is only one state. Okay, so this one subset means what? This is the only one state in the DFA, Q0, Q1. Now what are the new subsets? Q1 is a new subset? No, it's there. Q0, Q1 is new subset? Yes, so take it here. Here we need to find transition for Q0, Q1. Two states? No, this is the only one state. Q0, Q1 is only one state. So Q0, Q1 one state on 0. Where it's going? Refer the NFA table. How? Even though it's a one state here Q0, Q1, but in the NFA diagram these are the two states Q0 and Q1. So how to refer? We want Q0, Q1 on 0. Where it's going? So Q0, Q1 on 0 means first column. So I am just making the circle. So these are the values q0, q1 on 0 going to this q0, q1. So again I am combining here q0, q1. Again subset notation. Similarly, q0, q1 on 1. So this q0, q1 on 1. Where it's going? These are going to these states. What are the states? q1, comma q0, comma q1. So q1, comma q0, comma q1. q1 is common here. So q1 will be taken only once. So q1, comma q0, or this in sequence I can write this q0, q1. So this q1 and q1 taken only once. So q0, q1, q0, q1, and again subset notation. What is the new state or new subset derived? q0, q1 is here itself. Again the same q0, q1. So no new subset is derived here. So this is our final DFA state transition table, as there is no new subset is derived. And from this DFA state transition table, we can draw the DFA state transition diagram. How? How many states here? q0, q1, q0, q1. As I mentioned, q0, q1 is only one state. What are the starting state? Starting state is always only one. Here is a q0 is the starting state. Here also q0 starting state. Final state, q0 is final state. Here also q0 is final state. But in addition to this, wherever is q0 in the row headers, for example here q0 final. Is there any q0 here? No. Is there any q0 here? Yes. So this state also becomes final. Okay, as here is a q0. It may be part, also that state becomes the final state. So let's draw this three states, sorry. q0 is the final state. You can give the subset notation, it's an optional one, not required. Here q1 also one of the state, non-final. Again q0, q1 is one of the states. Subset notation, as q0 is part of the state, so it becomes the final state. Then q0 on 0 going to q0. q0 on 1 going to q1. I have explained how to derive diagram from the table in one of the basic video. Link is given above. So this q0 row is completed. q1 on 0 going to q1. So self loop. q1 on 1 going to q0, q1. So one transition. q0, q1 going to q0, q1 on 0 and going to the same state on 1. So it will be a self loop. So 0 oblique 1. If you observe this, this is our final DFA, deterministic finite automata. As from q0 there is only one transition for 1, only one transition for 0. Same from q1, one transition for 0, one transition for 1, and same here. But if we observe in this NFA table, there are two transitions for 1 from the q1, q0 comma q1. So we converted NFA state transition table to DFA state transition table like this, and from this we have converted this DFA. In the next section we will see one more similar example. Thank you for watching.